Hi everyone, welcome back. In this tutorial, we are going to learn how we can make a comparison between simulated and observed precipitation. So for the simulated precipitation, it will be in the sdfi format, and for the observed precipitation, it will be in the CSV file. So we can understand simulated precipitation like model output, for instance, WRF model, and for the observed precipitation from CSV file from the weather stations. So the outcome of this tutorial will be an image like this, where we have the color shading here is the simulated precipitation, and overlay by dot point observe precipitation. So each dot point in here stands for each individual weather station, and as you can see at each dot point it also have different color. So the color bar here stands for both the shaded regions and also the dot points. Okay, the first thing that we need to do in this tutorial is to load a library. There is a number of certain libraries that we need to import it. I'm not going to detail. For more information, certainly you can search in Google. And then the second step is that we load the sdf file, so or the simulated model. So I use xarray dot open dataset command to open the sdf file. I have sdf files in the folder named data, as you can see in the upper left here, and the sdf file. After that, we will take out the variables rain and sea. So I only take out the variable rain and sea because this is the convection permitting simulation. So the cumulus parameterization is switched off. That's why we don't have rain sea. And just for the purpose of keeping this information confidential, because it belongs to a process, so I make up data a little bit by using this two command lines. However, for the purpose of this tutorial, you don't need to understand this two. Just skip it and go to the next one. Next, we take out the latitude and longitude variable, so we can print to check the shape of the data, whether we extracted the right information or not. After that, when we are certain, we can go to the next step, where we will load the weather station data. So in here, the weather station data is in CSV file, and this is located in the folder data and then station data. So here on the left, I am in the folder data, and I have small folder named station data. When I enter this folder, there will be for CSV file. This for CSV file because it is for it. It stands for weather station for weather station. So as in another tutorial, when I talk about how we can open the multiple CSV file as well as nested file, we can also use similar command using the for loop to open the CSV file, and then use panda. PD here is stand for panda, which is one of the library, very useful and powerful library in Python. So to read the CSV file, so when I read the CSV file, it will return for me a table where I name this table for each station is df underscore, and then I will append or put the df underscore into the df CSV. So df CSV is a list. You can understand it's like a box. So for each station, which is we can understand each station is like an apple, and then we put an apple inside a box. So inside this DFCSV box, we will have 4 apples, stand for 4 stations. The next step is that we create a mesh grid. So we have a mesh grid here because we want to plot the precipitation data. For more information, you can certainly watch my other tutorial when I talk about the basic in NumPy. Okay, and then the next step is just to plot a figure. So in order to plot a figure, we need to manually create it a color bar, which is something like this one. Of course, we can also make default using the default color bar or CMap. However, for the precipitation, I prefer to manually create it. So in here, I have 10 different color, and then I will use this command to make a CMap. Just a note, in the Python Matplotlib website, there is many different CMap, and we can just simply use it. So in here, I manually created. I have CMap1 dot set over and dot set under, which I set to magenta and white color. As you can see here, upper triangle have a magenta color and lower triangle has a white color. And the next is about the specify the level. So it's from 5 to 60 and interval of 5. So it's from 5 to 55. 55 here because when we use the numpy dot arrange, I think, yeah, when we use the command, the function numpy dot arrange, it will not go to the last value. Instead, it go to the last -1. So that's why I specify its city here. The next step is that we plot a two-dimensional map or the simulated precipitation. We make a figure and then we use the command, the function Control F to plot a figure, capital X and Y here, corresponding to the X, capital X and Y in this step. And then we plot the rain NC, which is just the data that we extracted from sdfi at the beginning, as you can see in here. And then we specify the minimum and maximum, and we use CMap equal to CMap1 as we manually created here. The extent equal both here is just about to make the over, for instance, over 55, the color will all have the same color magenta, and less than 5, all the color will be become white. And this is for the levels, as you can see in this command. And then I make a color bar and set the label. As you can see, we have a precipitation in here. We can set the distance from the label to the color bar as well as the font size. And we can add the title X label, X Y label, as you can see, latitude and longitude, as well as the title on the top of the figure in here. So after that, we will plot the observed precipitation at the weather station as a dot point. So I used the similar color map. The reason because I want to use similar color bar so that I can compare directly what is the observed precipitation at the station to the simulated precipitation by the model. So that theoretically these 3 lines can be deleted, and yeah, but just for the purpose to show that we should use yeah, because before I plot this figure, I make 2 color bars, so I plot another color bar here to double check. However, the final figure here, I already turned it off. As you can see in here, the color bar is already turned it off. So, but it's a good for me to double check. And for this 3 line, theoretically we can delete it and use the CMap equal 1 here. And then here I have a for loop. For loop will go from 0 to 4 because we have 4 weather stations. So it will go through each CSV file, and then in each CSV file, it will take the latitude, index, and longitude. So in order to plot the scatter plots, we need to have a longitude and latitude. So it will, with the longitude and latitude, it will define a point on a two-dimensional the map like in this one. And then I also take out the precipitation amount as in this comment. So I will assign it into the FCSV precipitation and then put it in here. So with this section, it will specify, okay, at certain location, weather station, it will have a different color. For instance, because this is to only to specify color based on the value of observed precipitation. So as you can see here, each dot will have different color if its value is not similar. And then what else? So in here I have a marker. So you can see marker symbol here have an index I. The reason because I specify the marker here will have different shape. For instance, circle, rectangular, or square, or triangle. Then just to distinguish between different stations. Okay, once all this already done, we can plot a figure, and this is the final figure that we can see. Shaded regions stand for the model simulation, and dot point stand for the observed precipitation at each weather station. And okay, this is all done, and thank you very much for watching, and please let me know if you have any other questions, and please subscribe my YouTube channel too. So I recognize that I cannot share this data because it's confidential due to the fact that it belongs to a project. So I make another tutorial which is very similar, but I created artificial data so that if you guys watching this video can certainly practice by watching the second tutorial by using artificial data. And the final outcome of that tutorial will be an image like this one. Okay, this is all done. Thank you very much.